Welcome to episode 2 of Thinking Out Loud series. In this series, I participate in a Codeforces round, be it Div 2, Div 3, or Div 4, and I talk through my thoughts while I code the solution or while I am brainstorming the solution to the problems that I am attempting. If you watched the episode 1, you will remember that I massively overkilled problems A and B. They had just 5 lines of code to get an AC, and I ended up implementing 50 lines. So, one learning from the previous episode could be that let's try to keep things simple. Let's not do overkill unless absolutely needed. Because if you remember in problem A, you just had to print if if an entry equal to 100 was present in the array or not, and I actually ended up simulating this entire thing, which was which I was lucky because O of n square was allowed, but there did exist an O of n solution which did not cross my mind. And similarly for problem B, you will recall that I ended up creating a map with infinity and minus infinity, then iterating over the map, deleting some element while I was doing the iteration, and then getting confused about whether that is even allowed or not. While in reality, I could have just maintained a vector and then simply removed element from the back of the vector instead of trying to delete some element from the middle of a map. So we can take that as a learning from the previous video. Not that any of that matters right now for the current contest. For the current contest anyway, we start from scratch. So the contest is about to begin. I honestly don't know how many problems I will be able to solve. Last time I was able to solve last time I was able to solve 2 problems, that too after a lot of struggling. Let's see how many we are able to get this time. And one thing is for sure though, that if I am suffering, then you will also have to suffer with me if you are watching the video. So, but anyway, I will at least link down the problems that I was able to solve, right? And if I was able to solve, then even if my approach was incorrect at the start of this video, towards the end I might uh, actually lead you to the correct solution. So it might worth be watching on how to go from a WA solution or a WA idea to the correct AC idea. So we'll see how that goes. Now I think by now the round should have started. Let me refresh the page. This is the problem A. The problem statement already looks scary. So let me create a new page. First of all, I'll copy this problem statement and bring it to the whiteboard so that we can brainstorm. And let me also copy the test case. What does this problem say? You are given an array, okay? You wish to make the array empty by performing the following operation any number of times. What is the operations? Select any sequence of indices. This means that you are selecting a subsequence. Denotes the correct current length of A such that you are selecting a sorted subsequence. So essentially, you are selecting increasing subsequence. So you are selecting increasing. I mean, technically not increasing, that is non-decreasing, but anyway. So they are saying that you can select any subsequence and then remove them from the array, and the cost is equal to the product of the elements that have been removed. So you have to find out the minimum total cost required to remove all the elements from the array, and then you have to print it via some modulo. Note that the total cost is equal to the sum of cost incurred over all the operations performed, and the array length is just n is equal to 100 and the elements are between 1 to 100. So this is it. This is the entire problem. Now, how do we start approaching this? So let's again confirm that we are reading the problem statement correctly. So you select any increasing subsequence, you delete them, and the cost that you would incur is the product of all the elements in the subsequence. And you have to repeat this as many times so that you have to delete all the elements from the array A. So at first glance, this actually doesn't look like a diff2A. I mean, this itself looks very complicated problem, but maybe when we do some analysis on paper, it might get clear. So I don't think they will ask you to implement a brute force or something, because even though n is 100, you can't really iterate over all the subsequences. So brute force is out of the picture. We definitely have to make some observations. Okay. Now, what are some observations that you can make? Like if you have a sorted array, then the cost is what? Product of every element, right? Because in the sorted array, you can do this entire operation 1, 2, 3, 4, 5, etc. So is the cost actually in a sorted array, suppose this is the easiest example, is the cost actually product of all elements, or can it be something better? So now using some observation skills, you can notice that they did not mention the size of the subsequence, right? So you can select any subsequence, and you will of course notice that 1 into 2 into 3 into 4 into 5, this sum will anyway be much greater than 1 plus 2 plus 3 plus 4 plus 5. In fact, for any two numbers, a into b is anyway greater than a plus b. In fact, now I think we are going in the correct direction, because if you remember from your AMGM inequality, that product of a certain series of numbers a1, a2, a3 up to ak is always greater than. So what is the relation? I think it's the kth root is greater than a plus b, sorry, a1 plus a2 plus a3 by k, something like that. Like the geometric mean is greater than the arithmetic mean. So of course you can see that you don't have to prove rigorously, but you can see that taking two numbers in the subsequence is never optimal. You could just take one element and delete that element alone. Are we missing some corner case? What about the cases when we have one? I think this is a corner case. I think we missed this case in the last contest, because in the last contest we had to focus on the case where uh, AI was equal to 0 so that you could achieve the score as 1. Now, even though this AMGM inequality is kind of correct, but what if the array was all ones? So you see, even before coding it up, like I was going to code up a solution where I was just going to print all the sum of all the integers as the answer. But you see that if you did that, then in this round, you see that you could have just taken all the ones together and they would create a single one, and the cost is just 1. So this means that we have to be very careful with 1. But if the array did not contain 1, you can clearly see that this AMGM inequality is valid. So your answer is sum of all the elements that are greater than 1. So if it is greater than 1, you sum them up. And what about the elements that are not equal to 1? So for example, there will be a 2 here, there will be a 5 here, 9 here, 7 here, and so on. So for these kind of elements, you can see that every element will get its own operation. So you don't have to incur any extra cost for this one, because you can club this one with 2, right? And then you can club this one with 5, and so on. In fact, let's say, do we have to pay this extra cost for this one. So if you did not have any element to pair it with, then of course this one will incur an extra cost. But if you had something like 1 1 2 1 1 3 etc., then every element is getting its own round, right? In which that round you are only deleting this element. So you can club all the ones that appear as a subsequence to the left hand side with this element, and that will work. When this element gets a new round, you can club all the ones that get a new round with this element, and so on. This means that only the only the ones that could be left isolated is this 1 1 1 2 1 1 3 1 1. Now this last one, you cannot take it with this 3 or with this 2, right? This means that the answer to this would have to be 2 plus 3 plus all the ones should get their own round, right? So the answer to this should be 6, unless I am wrong. So this means that you just have to check whether, so if there is no terminal ones, like you can say something like, if you have this scenario 1 1 2 1 3, then there is a terminal one, but you can do the pairing like so. This gets deleted in one round and this gets deleted in one round. But if there was a scenario like this, then also you can do similar pairing like 3. No, can you do similar pairing? No, you cannot do, because after 3 you cannot pick one, because you have to take a sorted subsequence, right? So this means that if you have this situation, you are good. Your cost will only be 5. But if you have an extra one remaining after the last greater than one integer, this series of one, they will require their own block. But if they require their own block, you could just use that block to delete all the ones together, right? And then you delete 2, then you delete 3. So the problem is basically asking you to find, is there a series of suffix ones, and if there is, then if there is a terminal one, then the terminal ones will require their own round to delete all the ones, and when they do, they can even take all the internal ones as well. But that is not strictly needed, because the internal ones can get consumed by their right neighbor, because every element that is greater than 1, they will participate in their own round. Why? Because of this AMGM inequality. Now another thing that we have to keep in mind, that the problem is asking you to print the answer modulo this, because the answer is the product of something, and this product can be huge. But actually, if you think about it, this is a red herring, because first of all they will never introduce modular arithmetic in problem A. I think so, because anyway, we have seen that the answer is simply sum of all elements plus an additional one, right? So sum of all elements cannot uh, exceed this modulo, right? So we are good. So we just have to implement that strategy. So let me implement it. We get the size of array, and we check if there is a terminal ones or not. Terminal ones is equal to false, and we check if a dot back equals to 1, then it is a terminal ones, right? And then we remove all the terminal ones, because they will get their own rounds, while a dot back, while not a dot empty, and then a dot back equals to 1, a dot pop back. And we compute the cost. So the cost is terminal ones. Like if there is a terminal 1, then the cost is 1 for that round. Otherwise the cost starts with 0. Now for all the internal elements, we need to count all the elements that are greater than 1. For integer element in A, if element is greater than 1, cost plus equals to element, and then you print cout cost this, and this should work, I believe. Now in retrospect, you see that we would have arrived at the same conclusion a lot earlier if we had seen the samples, but anyway, still a good exercise to come up with this idea. 761 so the code should be correct, and anyway there will not be overflow because sum of all the elements could be 100 into 100, which is 10 to the power 4, so we don't have to use long. So I go to submit code and submit this problem. Then let us also read the second problem. Let's prepare the whiteboard for the second problem. This is running on, so it worked. So it should be correct. There is no doubt about it. So rank is, what is the rank? This is the score. Rank is 4500. Okay. So this guy Aryan, this looks like a smart guy. He has already solved 2 problems. So okay, let's talk about problem B. First I'll copy the problem statement. And then I'll also copy the constraint. Don't really need to copy the constraint. We can just look at it. It just says that n is up to 10 to the power 5. So that should be fine. So an array is called good if the difference between the maximum value and the minimum value in the array is equal to the GCD of all the elements in the array. Okay. Note that an empty array is considered to be not good. Okay, fine. More formally, this is the definition. Okay. You are given a permutation of length n. Determine the number of good subarrays in the given permutation. So maximum minus minimum should be equal to the GCD. Now, how do you even start to think about this problem? So off the top of my head, right, I can start throwing some ideas that GCD of odd comma even is equal to 1, right? GCD of 1 comma something is also 1. So you need to find out how many number of good subarrays are there in the given permutation, and you are looking for the maxima minus minima. So the GCD could either be an even number like 2, 4, 6, etc., or an odd number like 1, 3, 5, 7, etc. How do you find out the number of good subarrays though? Okay, if that is the case, can we start with any fixed subarray and find out when it will be good, right? Can we do that quickly? Like if this is the subarray S that we are dealing with, and suppose we know the maxima and we know the minima, right? This is the maxima and let's say this is the minima. So all of this boils down to quickly computing the GCD of all the elements in this array. And one way is that we can use some contribution technique where we fix this element I, and we ask the question, how many subarrays are there, how many good subarrays are there that start at index I, and how do you compute that answer? That part is easy. You use two pointer, you start from here and then you keep going right, keeping track of the maxima and the minima, and also keeping track of the GCD, and at each round when you reach stage J, you compute the answer for I comma j. So the time complexity of that is O of n square, right? And maybe additional factor for log n, that's not as important. So can we optimize this directly? Like, is there a very simple optimization that we are missing? I think that optimization has to come from here, like max minus min. What does max minus min actually mean? So GCD is max minus min. Hmm. What can we try? Number of good subarrays. I think the O of n square strategy is very clear. How do we actually optimize it though? That is the question. GCD, and we have to keep in mind that this is a permutation. So is this actually helpful? Because if this is a permutation, then it will have 1. So let's say if I try to find all the subarrays, if I try to find the answer for all the subarrays that start at 1, their GCD will always be 1. So the right hand side is always 1. So we are looking for all the subarrays that are equal to this. Max minus min is equal to 1. So max is equal to 1 plus min. So and min is anyway 1. So max is equal to 2. So since this is a permutation, then if 1 and 2 live close by, only then this is a good subarray. But if there is at least one gap and 2 is not over here, then there can be no good subarrays that start at this index. So that's fine. That is the simplest possible answer for 1. Can we do some analysis for 2 as well? So we are doing some random stuff because we are not able to find the solution. So for 2, you will notice that for 2 you want to find out for 2 the GCD values can actually be 2, 4, 6, 8, etc. And GCD can actually be smaller than 2 as well. GCD can also be equal to 1. But uh, minimum that that is not helping. Maybe we need to approach it from a different angle. This is diff to b should not be that complicated. I don't know why the solution is not coming to me, but I am convinced that this entire logic lies in this, like max minus min. Max minus min is equal to GCD. Maybe if you can quickly look at an array and figure out if this condition would be satisfied, then we would be able to optimize this O of n square solution idea that we just discussed. How do we do that though? Max minus min is equal to GCD. Can we do something like maybe fix this as min, and we know uh, if this is the min, suppose this element, consider this element, and assume that this element will be the minimum in this range, and it will also be the minimum in this range. Then can you claim something about this equation? So minimum is fixed, but you cannot claim anything about the GCD or max. Actually, another thing that we could try is, why did they give a permutation? Like why did they not give duplicate elements, or why did they not give elements up to 10 to the power 9? So definitely it has to do something with the values of the permutation itself. And if you look at the constraint, so you see that it is only up till PIs are only up to 2 into 10 to the power 5. So can we use some sieve-like algorithm where we say that if you know how to compute all the divisors of any number, it goes something like this. You start at 1 and you mark all the multiples of 1, right? Then how do you compute all the divisors for 2? You start at 2 and you mark all the multiples of 2. So when you take the GCD of so this is 2, 4, 6, etc., then you can be sure that GCD of, so if you are marking all the multiples of 2, then if this is x and this is y, then you can be sure that GCD of x comma y is a multiple of 2. So it is 2 into something. So can we apply some similar strategy over here, some sieve-like strategy? Max minus min is equal to GCD. Maximum element, this is the mx, this is the minima, but what is the relation between them? GCD can be, mm, number of good subarrays in the permutation, maxima minus minima is equal to GCD. Maxima minus minima. I think in most of the cases, GCD would be 1, because if you have a permutation, unless you have a good number of even numbers together, then if you have good number of even numbers together, then GCD is 2 into something. But even if one odd element lies here, then the GCD is odd. So you can think of it like so. If you have an even plus odd combination, so let's see what happens. In that case, max minus min is equal to GCD. GCD of even and odd is equal to 1. So max is equal to min plus 1. But how can this be? How many elements can there be? So if min exists, then min plus 1 should also exist. This means that if you have an even and odd combination, then you should only have 2 3 pair or 3 4 pair, 4 5 pairs. So see, these arrays of length 2, they are the only possible even and odd combinations that produce GCD 1, and their difference is also equal to 1. So this means that you can group all the even elements together. This is all the even elements. This is all the odd elements, then all the even elements, then all the odd elements, alternating like so. And in this even element set, you could kind of do the same thing like you take out the common factor as 2, and then you would again be able to split this element, because if 2 is common, and let's say so if all the elements are even, so max minus min is equal to GCD, right? So if all the elements are multiple of 2, right, if all the elements are multiple of 2, then you can take out 2 factor from here, and you can take out this 2 factor from here, and you could do GCD, and GCD will also be a multiple of 2, so you can actually cancel these, and you kind of arrive at this same logic. This means that I am getting a hunch that the subarray that we are looking for, that cannot be very big, right? This is one bold claim that I am making. I don't know if it's true or not, we'll have to prove it. But this subarray, this good subarrays are small in size, not in number, small in size. Because like I said, like if you want to consider 2, 4 and 6, so their GCD will be equal to 2. So maxima should be equal to 2 plus minima. So this means maxima should be equal to 2 plus minima, and anyway you cannot have odd elements in between. So 2 4 6, in fact 2 4 6 also does not work if you look at it, because you can take 2 common, and then it is 1 2 and 3, and you see GCD of this is odd, because it is a product combination of odd and even. So GCD is odd. Sorry, GCD is 1. So if the GCD is 1, then maxima, so GCD of this internal thing is 1. So 2 is, so see, all of this is hinging on this fact. Max minus min is equal to GCD. Then if all the elements have 2 as a factor, then you can take out this 2 entirely, and this equation should still be satisfied, because you can divide max by 2, you can divide min by 2, and you can also divide the GCD by 2, And then you can see that if the array is of length 3, even then it will not work, right? And anyway, you can't have duplicates. So are we heading towards the correct direction? Like, can we even make some more bold claims that only length to subarrays are a possibility? Only length to subarrays are a possibility. Can we make this bold claim? Only length to subarrays. Let's let's verify by checking the samples in this one 1 2 3 4. So you see that 1 2 they will have, 2 3 will have, 3 4 will have. So that's why the total amount is 3. So I think this idea is correct. I did a lot of guesswork, but I think there was some like reasoning to it. Should we prove this formally, or should we just code it and then pray to God? So let's see. Let's try to prove any array with length greater than or equal to 3 cannot have. So let's prove this. Length greater than or equal to 3, no answer, right? So let's start with just 3 elements. If we can prove this, then we can do some inductive reasoning or something. So if you have ABC, if you have ABC, then either all of them have a common factor, either GCD is equal to 1. Like if GCD is equal to 1, it means you have odd as well as even elements, right? No, I mean not necessarily. GCD of 3 comma 5 is also 1, but 3 5 and 7, GCD of 3 5 and 7 is also 1. Doesn't mean you have a combination of odd and even element, but this just means GCD is equal to 1 means they don't have a common factor that can divide all of them. So if the GCD is equal to 1, then this equation should satisfy max minus min is equal to G, and G is equal to 1. So it should satisfy this condition. Max should be 1 plus min. So if min is over here, then you can only have m plus 1. So you cannot have an array of length 3. So that's fine. Now assume that all of them have a common factor. GCD means, right, I think now we are going in the correct direction. GCD means every number can be written as G into GCD, G into GCD, G into GCD. So why don't we write maxima as G into some m star and minima as G into some like mn star, and this is mx star, and right side is G. So right side G's cancel out. So you have mx star minus mn star is equal to 1. This means that we are 100% sure that only length 2 subarrays can be the answer. And now I think we have solved the problem, just need to implement it. And when the length 2 subarrays, so you do the same thing, like you define dp of I as the number of subarrays starting at I, and then you check if I and I plus 1, if their difference is odd. If their difference is 1, then you have your answer. Otherwise the answer is no. So I think yeah, I think we have solved it. Let's move on to the implementation. It was a rough road to solving it, but a solve is a solve. Integer n is equal to a dot size, and then you define something like vector int dp of n, initialize it with 0. You define dp of I. dp of I is the number of subarrays starting at I, number of good subarrays starting at I. Good subarrays starting at I. Can a length 1 subarray be the answer? Let's check. Did we miss some corner case? For a length 1 subarray, maxima minus minima is 0. So GCD cannot be 0. So we only have to check length 2 subarrays, right? So you do for int I is equal to 0, I less than n minus 1, I plus plus, and you look at the right neighbor, right? So you check whether if absolute difference of ai minus a of I plus 1 equals to 1, dp of I is equal to 1, right? Otherwise dp of I is equal to 0, and you print cout accumulate dp dot begin dp dot end and 0. Now let's check if this is actually correct. One zero three. Yeah, it looks to be correct. Time for the verdict. We spent 45 minutes in solving A and B. Not good, but not bad either. This is incorrect. Interesting. So if the difference is 1, GCD would always be 1 and max minus min. Mm, what is the flaw? What is the flaw that we are making? Because I think our arguments look pretty solid, unless I've fooled myself, but arguments look pretty solid. Maxima minus minima is equal to 1. Oh, actually, yeah, one thing we forgot that, yes, yeah, one thing we forgot. So if you see 4 comma 6, right? So 6 minus 4 is 2, and their GCD is also equal to 2. And what did we forget? This one. So when we factored out this, so we said that max minus min is equal to 1. So notice that here we said that mx star and mn star should be, their difference should be equal to 1. So when you actually multiply the GCD, right, and then you get the original elements. So their difference should actually be equal to their GCD, not difference should be equal to 1. So you should have something like, if absolute is equal to GCD of AI comma a of I plus 1, this should work. Let's compile it again. I hope it works this time. It passed pretest too, so it should be correct. Yeah, I think it's correct. Yes, we did it. What is the rank now? Okay, 4,900. That's good. Now let's move on to C. Let's move on to problem C. Mental monumental easy version. Again the same drill. Let me first copy the problem statement. For any array, define f of c as something like this. Again, this is a problem involving max, and okay, so this is a problem involving max, and let's read the constraint. Constraint says that n is the standard 10 to the power 5, and ai's are up to 10 to the power 6. Okay, it's guaranteed that the sum of maximum is does not exceed 10 to the power 6. That's fine. So what are they saying? For any array C, we define f of C as the maximum possible max. Okay. That can be achieved by performing the following operation exactly once. What is the operation? Choose an integer array b1 to b1 bn. Okay. Select set ci is equal to ci mod bi. Okay. You are given an array consisting of n integers, non-negative integers. Determine the value of f of a. So you want to maximize the max. Okay. So, and how many times you can do this operation? You have to do it exactly once. And okay, you have to do it exactly once, and bi you can select arbitrarily, you see. But anyway, taking bi, so if you take bi greater than c star, where c star is the maximum, then it doesn't really change anything, right? So bi anyway is constrained by the maximum value over here. And then you want to take ci as ci modulo bi. Okay. How do we solve this? We can do this conversion like each element. Okay, so we actually have a choice. We actually have a choice, independent choice for B1, B2, B3, and so on, right? Up to Bn. So what is the theoretical maxima that we could achieve? So theoretical maxima is what? You know that the max of a list of size n is equal to n. So can we actually achieve n? Or can we actually achieve m, which is the size of the list? You can only do that if you are able to achieve a 0. So if you look at this number line, if this is 0, 1, 2, 3, 4, 5, 6, and so on, then you have to achieve this 0 first. You have to achieve 1, 2, 3, 4, and 5, so that the max could become 6. But how do you achieve a 0? So either 0 is already given to you, but even if 0 is already given to you, in that case you can just select bi as infinity and your 0 will not be affected. But if 0 is not given to you, then you have to create a 0, otherwise your max will become 0. So which element will you pick to create a 0? There are multiple choices. Okay, so there are multiple choices and we don't know which element to pick to create the 0. And what are the constraints? Let's see. The constraints for AI are 0 to 10 to the power 6. And the sum of maximum values does not exceed 10 to the power 6. I don't know how we will use that constraint, but let's see. Again, I'll copy this problem statement. Choose an integer array. So our goal is to see, even if we don't achieve the maximum, I think a greedy strategy kind of works over here. Why? Because if you do not achieve a 0, if you do not achieve a 0, if you could, then your max would be equal to this 0, right? If you leave a gap over here. Or if you do not achieve 0 as well as 1, if you could, then it doesn't matter what bigger values you achieve to the right hand side. So this is just like the lexicographical order that we deal with. In the lexicographical order, if you don't respect the first I elements, then it doesn't actually matter what you did after it. The answer will be decided by this element itself. So like we said, how do we achieve a 0? Either it is already given to you in the input, or if it is not given, then some Ci is greater than 0. You take that Ci and you convert it to 0. How? By selecting that Bi as Ci, right? First of all, let me actually look at the hard version. What is the hard version trying to find? Is it asking you to find the array or something? Okay, this time you're required to find the values of f for each prefix of a. Okay, maybe some dynamic programming involved, or I don't know. But okay, for each prefix, you have to determine the value of f of a of 5. Hmm. So this means that definitely does not involve fancy tricks like dynamic programming for at least this version. There should be a very simple brute force algorithm, and this should lead us to the solution of E. Uh, Maximum possible max that can be achieved by performing the following operation exactly once. So can we define something like, suppose you have this prefix, so if the answer to this prefix is, let's say, m, then what will the answer to this bigger prefix be? So this means that you have on the number line, you have already filled up all the gaps between 0 till m, right? This is m minus 1. So you have already filled up all of these gaps. This is the best that you could do with this prefix. Right now I'm trying to see if I can extend this prefix further or not. So if this is the best that you could do, if this is the best maxima that you could achieve, then there is a configuration in which you have filled up all of these gaps. Then when the new element arrives, the max can only increase by 1. Is that actually true? Mm, that might not actually be true, because it's possible that you have filled all of these elements over here, and then you have you have also filled all of these elements, but you could not fill this element, and the incoming element that will fill this gap, and max can increase further. Okay, but at least we can see that max will always be an increasing sequence, right? So when you are processing the prefixes, you can keep track of how many gaps that you have filled so far. But how does it help us? So let's look at any number in the original array x. What all values can it be converted to? It can be converted to a 0. I think it can also be converted to a 1, because if you do x modulo x plus 1, then you are good, right? Similarly, if you do, no, actually that's not correct. If you take any element, right now we want to focus on one element, x, and we want to see what all states can it reside in. So x can it be 0? Yes. How? By doing x modulo x. Can it be 1? So for it to be 1, if this is x on your number line and this is 0, for it to be 1, you have to take modulo with x minus 1. Is that correct? Let's see. If you have a number 9 and you take modulo with 8, is this equal to 1? Yes, I think it's equal to 1 because 9 is equal to 8 into 1 plus 1. So this will cancel out and you will get the remainder as this. So I think 1 is also achievable if you take it with x modulo x minus 1. Is 2 achievable? Yes, if you take the modulo with x minus 2. So in fact, I think everything should be achievable, right? So what is this bi constraint for? Ci mod bi, and you can choose any integer array and you have to do this operation. Okay. But bi should be equal to greater than or equal to 1, which makes sense. So suppose you are dealing with 9. Okay, for 9, if you take modulo with 9, your answer is 0. If you take modulo with 8, so 9 is equal to 8 plus 1, your answer is 1. If you take modulo with 7, because see, each of these indices are different, right? Like the one index cannot affect the other one. So if you do 9 modulo 7, you get 2, right? Do you get 2? Yes. If you do 9 modulo 6, you get 3. 9 modulo 1, you get 9. Or do you get, no, 9 modulo 1, what do you get? 9 modulo 2, you get 9 is equal to 2 into 4 plus 1. So you get 1. Mm, wait, how come you are getting 1 again? Okay, maybe our assumption that for any number x, all the modulo from 0 to x is achievable is incorrect. I think that kind of makes sense because, yes, I think that makes sense because if you look at this x, actually let's list down, let's not guess, let's list down all the possibilities for 9. So 9, and we are creating this table, and let's see when modulos start repeating or wrapping around. So 9 modulo 9, 8, 7, 6, 5, 4, 3, 2, 1. So what is the remainder when 9 is divided by 9? 0. What is the remainder when 9 is divided by 8? 1. What is the remainder? So 9 is equal to 7 plus 2. So remainder is 2. 9 is equal to 6 plus 3. 9 is equal to 5 plus 4. 9 is equal to 4 plus 5. 9 is equal to 3 plus 6. Okay, actually I'm doing something wrong. So 9 is equal to 2 plus 7. 9 is equal to 1 plus 8. But actually all of that is wrong because that's not how you uh, take a modulo, because when you're taking modulo with 8, the answer has to be less than 8. So when you took a modulo with 5, this is correct, but from this point some divergence is happening. Because when you take modulo with 4, so even though 9 is equal to 4 plus 5, 9 is equal to actually 4 plus 1. So the modulo actually starts repeating from here. You will see that it is actually 1, and then 9 is equal to 3 into 3. So this is actually 0. And then 9 is equal to 2 into 4 plus 1. So this is actually 1, and 9, this is 0. So will this pattern continue like 1010, or is it just a special case for 9? How much time do we have left? 1 hour 15 minutes. Why is this 1010 pattern appearing? Can we try for 7? Let's try. So 7, again you do the same thing. 7 modulo 7 is 0. 7 modulo 6. So 7 is equal to 6 plus 1. So modulo is 1. 5, 4, 3, 2, 1. 5 plus 2. 4 plus 3. 3 plus 4. 2 plus 5. And 1 plus 6. But now modulo should always be less than that number. So you have to do repeated division. So this is fine, this is fine, this is fine, this is fine. But this, so this means 4 is equal to 3 plus 1. So this is actually 1. And 2 is equal to 4 plus 1. So this is also 1. And 1 is equal, and this 1 is this 0. There is no pattern as such, but I think from this point onwards, whatever is happening, I think the max modulo, you can safely assume that the max modulo that you can achieve is only x by 2, no more than that. Again, I'm going to make a very bold claim over here that the max modulo is that you can achieve is x by 2. And whether it is floor or whether it is ceiling, that we'll have to see, but it should be roughly around x by 2. And now this is just a claim, but let's see if that claim is actually true or not. So if this is x and this is the midway point, x by 2. So what happens when you take a modulo? Numbers from when you take modulo with x, then all the numbers will, so if you have this, like if you select the modulo, so if you want to take modulo with k and you select any number from this half, right? So you know that x modulo k is always less than k. So if you select a number in this half, the result will always land in this half. So if you want to maximize the values, then you have to select the numbers k from this half, so that it has a possibility that the numbers land in this half here. So if you select a k from here, so the resulting modulo can either land on this half or this half also, but it has the possibility of landing on this half. But is it actually possible to achieve all the range, like everything from 0 to x by 2? Can you actually achieve? Mm, how do we find out? Can we actually achieve? Like right now, we have just concluded that the max that you could make is x by 2. But why is this claim correct? Like why is the max that you could make x by 2? Because I said that when you pick a number from this half, it can either fall in this half or it can fall in this half. But this is a very special scenario, I would say, because if you have this x by 2 over here and this is x, so let's visualize modulo as some distance on this number line. So if you were to travel a distance of d over here, then what is this distance? X by 2 minus d. So this entire distance was x by 2 from here to here. So what is this distance? X by 2. And when you have a number x over here, uh, sorry, when you have this number x over here and you have a k over here, then when you take a modulo with x, you can write x as, so since this number is smaller than x, you are finding how much extra does it need. No, for this one, so if x is greater than k, then will the modulo be equal to this distance, or will it be equal to this distance? So let's take some examples. This is like, let's say 23, and 23 by 2 is 11. Yeah. Then suppose you want to take this 12. So what is 23 modulo 12? Are we even going in the correct direction? I don't want to invest too much time on it just to realize that we have been going in the wrong direction, because we are not able to formalize what are the possible values that you can achieve. Because if you were to formalize, so let's forget all of these computations for once. Okay, so we have 1 hour remaining. Let's forget everything. Let's start from a clean slate. And suppose given an x, there is some algorithm that can give you what all modulos can it actually achieve, right? It can give you what all modulos can it actually achieve. In that case, would you be able to solve this problem? So what strategy would you apply to maximize the max? What would you do? So maybe you would do something like this. You will maintain a list saying which indices can achieve a 0, which indices can achieve a 1, which indices can achieve a 2, and so on. So here you will maintain a list of indices I1, I2, I3, I4, and so on. And here also you will maintain Z1, Z2, Z3, Z4, and so on. And there could be some overlapping as well. So you want to create as many uh, elements, consecutive elements starting from 0, right? The first element that you cannot create will be your max. But then how do you decide which element should get a 0? Should it be I1 or should it be I2? Because it is possible that I2 can achieve 0 and 3, right? So suppose I3 can achieve 0 as well as 3. But if you assign 0 to I3, when you had the option of assigning these to other elements as well, then by the time you reach position 3, I3 has already been used up. So you cannot reuse it anymore. So even if you had this list somehow, and we'll figure that out later, sooner or later we'll figure it out for a given x, what are the values we can achieve. Even if you had this list, would the problem have been easy? No, right? Like we still have to come up with a strategy that retains all the future i's, and still make sure that we are able to assign all the indices consecutive values from 0 to n. So let's focus on this problem first. Like we'll come back to the possibilities later. In fact, the possibilities part, in fact, I think since the values are only from 0 till 10 to the power 6, right? Maybe we could even just simulate, and I don't know, maybe we can. Okay, I mean that's fine. We'll worry about that later on. What values can X transition into? But for now, let's assume that for each element we know what all values it can transition into. For each value, we know what all it can transition into. And the time complexity is, for problem C, it is 2 into 10 to the power 5. So how do you end up assigning everything from 0 to uh, how do you do this assignment so that everything gets matched as greedily as possible? But how do you do this? How do you do this? I think this is kind of like a matching problem, but not really, because you have to do this greedy matching. You don't want to maximize the number of matchings, because even if this is matched and this is not matched, then your answer will be this, right? So how do you do this? How do you do this? Hmm. I1, I2, I3, I4, etc. Which element should you pick? Because it is possible that in this version, right now we are focusing on this version where assume that we have figured out which values are possible, which values are not possible. Then we want to find out zero, 1, 2, 3, 4, 5, 6, 7, 8. And 0 can be achieved by several index I1, I2, I3, and so on. Similarly, 1 can be achieved by Z1, Z2, Z, or let's say I5, I3, I7. 2 can be achieved by I6, I9, etc. So with this, how do you do the matching such that this prefix, one proper, the longest prefix has gotten the matching. Now all of these, will they be in a contiguous range, like all the values that any index achieves, will they be in a contiguous range from 0 to like let's say x by 2? Because if it is actually a contiguous range, then maybe that simplifies things a bit, because in the 9 we saw that it was actually a contiguous range, right? And here also it is a contiguous range. So I think maybe we have to explore that idea. So if this is x, then from x you have to go down, and you have to, you know that each element can be in this state from 0 till x, 0 till x by 2, and an additional x if you want it. I think this part we are certain. So how do you utilize this fact though? So if the number of elements is n, first you would try to make the entire max as n. Uh, so if you want the max as n, this means that 0, 1, 2, 3, etc. should be present in the array. So when can this be present in the array? Mm, can we do some sweep line thing? Something like you have this number line and you have 0, 1, 2, 3, 4, 5, and 6. So the first element can exist in states 0 till 3. The second elements can exist in state, so sorry, every element will, and an additional state over here, like let's say 6. Second element might exist in state 0 till 2 and an additional thing over here. Let's check with 4, is it actually correct? Like with 4 you can you achieve a modulo 2? So 4 modulo 4 is, 1 second, with 4, if you take modulo 4 you will get 0. If you take modulo 3 you will get 3 plus 1, right? So that is 1. If you get modulo 2, so it is completely divisible. So it is actually 4 by 2, which is equal to 2. So this means that x by 2 is strictly less than. So an element can only exist in the form, x can only exist in the form which is strictly less than x by 2. Let's check for an odd number. For 5, 5 modulo 5 is 0. 5 modulo 4 is 1 because it is 4 plus 1. 5 modulo 3 is 3 plus 2. 5 modulo 2 is 2 plus 3. But again, this time it will now wrap around because this time it will be less than 2 and it will be less than 1. So as soon as you cross this boundary, yes, I think now we are having some clear arguments about why this is correct, because once you cross this boundary, like if this is your x by 2 boundary, then all the modulos in this range will reside in this range only, and all the modulos in this range, they increase linearly from 0 till x by 2. So for 5 you see that 5 by 3, this is the floor and the floor is 2. So you can say that x can exist in this. So for 4, 2 is not achievable, but for 5, 2 is achievable. So how should we write the formula? What is the fancy way to write the formula? Because we can't just say that uh, 5 by 2 floor is not achievable. So maybe you should say something like, or let's not make it complex. Let's say something like this. If it is odd, it can exist, you can achieve this many numbers. If it is odd, then you can achieve x by 2 floor, right? You can achieve this. And if it is even, you cannot achieve x by 2, but you can achieve everything smaller than x by 2. So that's why this bracket over here and this bracket over here. Maybe there is a fancy way to to write it in a neat way, and anyway x is still achievable. We have 52 minutes remaining. Okay, so let's again verify this. For we did the verification for 4, for 5, and for 6. So for 6 we are claiming that 6 by 2, which is 3 should not be achievable, but 0, 1, 2 should be achievable. Is this actually correct? So 6, so divided by 6, 5, 4, 3, 2. With 6 answer is 0. With 5, 5 plus 1, 4 plus 2, 3 plus 4, right? 3 plus 4, and the modulo will of course be strictly less than 3 when you take a modulo. And so once you take since it is strictly less than 3, we don't really care about it. So our hypothesis is correct. And with 7, we already saw that with 7 you could achieve till 3, right? 7 by 2 is 3. 7 by 2 is 3, and our formula is valid. So even though we have not solved the problem, this part we are 100% sure is correct, that one element can exist in these many states only. And in fact, this is actually correct, that this interval thing that we are doing, right? Maybe we are going in the correct direction. So one element can exist in these states. Now, how do you take one, like, from each interval you can only take one element, right? So how do you take it such that you are able to construct this sequence where you have a prefix that is taken? So how do we do that? I think we are going in the correct direction, just have to figure out some things. So this number line interpretation, this is definitely correct, I have a feeling. So this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. So one element could be in this range, one element every, so 0 can be achieved by everything. Okay, so now I think we are getting somewhere. So if you notice, the prefixes, they can be achieved by anyone, right? So which element? So suppose, let's consider the smallest interval, and this element, for this element it will have 0 x by 2 over here, and it will have x over here. So should this smallest interval exist like so, or should it exist in this form? It can either exist in this form or this form. So the question is, who should get the responsibility of converting to a 0? Who should get the responsibility? Because anybody can convert to 0. So 0, I think, is not of that much. So it's a double-edged sword, right? Because if you don't respect 0, then if nobody gets converted to 0, then the max will become 0, right? So all that optimization for nothing. But since everybody can achieve 0, you are better off trying to construct a max over here on the right hand side, and then fill everything towards the left hand side. So, but how do we actually formalize it? Maybe can we do something like fix the max as m, and then if I tell you that everyone has to achieve the max as m, what strategy would you apply? Then you could do something like, if this is m, then all the elements that could exist on the right hand side, right, they will definitely exist on the left hand side. Like, no need to waste those resources, like they can take a form from here to here, etc. So you have all of these uh, free elements, but then how do you ensure that? So you have to ensure that m minus 1 is present. So if multiple elements can achieve m minus 1, maybe we have to do some simulation only, but in a smart manner. So if this is m, this is m minus 1. So if multiple elements can actually achieve m minus 1, then I think picking anyone is fine. Because if an element can achieve m minus 1, then they can also achieve all the smaller values as well, right? So here you can actually be greedy and pick up anything. So this means, can you do a can you do a binary search? This is just a shot in the dark. Like, actually, binary search, in my last video I discussed that binary search does not work on max related problems, but because there is some certain catch there for max related problems. But can we do a binary search over here? Like suppose if we fix the value as m and we say that is it possible to make all the elements less than or equal to m? So if you fix m, then a greedy strategy works, right? You keep going towards the left, and if at any point you are not able to cover that point, then you know that less than or equal to m is not possible. So if it is not possible, then the answer is at most m, right? The answer cannot be bigger than m. But if it is indeed possible, then you have found one answer as m. So can you actually remove this left half? I think you can, because your answer will be strictly greater than or equal to m, right? Yeah. So is this binary search idea correct? Because I think once you fix m, then a greedy strategy works. So again, let's formalize this. We have 45 minutes remaining. So if you wanted to know if the answer is less than or equal to m, then if the answer is, sorry, you want to know if the answer is, can the max be greater than or equal to m, right? If it is greater than or equal to m, it means that all the gaps from 0 till 0 till m minus 1, right? This is m minus 1. All There should be a way to fill all of these gaps, only then the answer will be greater than or equal to m. But if there is no way to fill all of these gaps, no matter what strategy you choose, then the answer will be strictly less than m. So this means if an answer exists where you have to maximize the max, right? That's what you have to do. Yes, you have to maximize the max. So you can do a binary search, and if you do find a way to arrange, if you do find a way to fill all of these gaps, you only need to worry about, can I increase the answer even further? So you trim this left half. And if it is not possible to make the answer greater than or equal to m, it means that one hole is still remaining over here at 1 or 2 or 3, etc. So if you could not make answer at least m, you cannot make the answer at least m plus 1. I think now we are going in the right direction. We actually have to do a binary search. Okay, and when you are doing a binary search, if you have fixed this m, then a lot of intervals will be covering this point, and a lot of intervals will be covering m minus 1, etc. So for each of these intervals, you take them greedily, right? Because if anything is covering this, it is also covering this as well. Now there are two types of coverings that are available, right? One is this covering this interval, and one is this dot. So at any given point of time, suppose a dot is covering it as well as an interval is covering it. So which one should you prefer? Like when you are going down and you encounter this scenario, this element can be covered by this, and like let's say this. So which one should you prefer? So you want to maximize your chances for uh, all these smaller elements. Like a smaller element should have a lot of possibilities. So if you have a dot representing over here, so you should take that dot. Otherwise, or should you? Because if you take this dot, then if you take this dot over here, then you will not be able to cover this interval. Like you will lose the possibility to cover this interval over here. This is getting too complex. Mm, And even if you did a binary search, like let's look at problem E. So in problem E, they are asking you to find the answer for each prefix. Each prefix of A. Hmm. For each prefix of A. How do we do this? I think binary search, I can code it up, but I think even the binary search idea, so binary search idea is correct, but it's not clear how to, for a fixed M that we are dealing with, how do we efficiently assign, like how do we greedily assign or optimally assign the values such that they form, they do not create any gaps over here. Mm, mm, mm. So let's say this element that you are encountering m minus 1, it can either be covered by an interval or it can be covered by a point. Which one would you take? Let's formalize. So if you take this point, you will lose this contribution because this point will have a corresponding, if this is x, then this is x by 2. But that is fine, right? Because if you take this one, then you will lose this entire possibility, this big possibility, and here you are only losing this possibility, because if an interval has extended till here, then it can support a lot of elements. So I think one thing is clear, that given the choice, we can write it formally like so. Given the choice, prefer a point instead of an interval when iterating backwards from M. So when you are given the choice, you should always prefer a point instead of an interval. Why is this true? Because if you are at this location, then interval can only originate from 0. So this is a bigger interval. And if this is a point, it will also have a smaller interval over here. So it is fine to lose this, but it is not fine to lose this bigger line, because this is a subset. Like this smaller line is a subset of this bigger line. So we can do a greedy approach where we always select a point. Okay. Now, what happens when you encounter two intervals covering it? Which one should you take? Actually, it doesn't matter, because since you are going from right to left, right? So we have already done all the assignments on the right hand side. So you can just take any interval and that's fine. But what about the points that are on the right hand side of this, right? They will act as an interval on the left hand side over here, like let's say. So we don't want to waste these points, so we always want to convert them to interval, but anyway we will convert them to interval, so that should be fine. uh, how do we do this then? So we have to do a binary search, that part is for sure. We have to do a binary search, and then we have to do some greedy assignments where you prefer a point first and then an interval, and if you can cover everything, then that binary search is valid. How do we implement this? So for implementing, you could keep a frequency, not really a frequency array, but But so if you have solved this problem on if you have solved this problem called minimum number of platforms, which is a very famous lead code problems, I think there they use this trick, right? Where if you want to store interval information from here to here, so this interval covers from here to here, right? So you add +1 over here and then you add -1 over here, and that way when you reach this element you will know how many intervals actually cover it. So that's fine, but how do we track the points, like how many points cover it? Because yeah, I think we can keep track of the points that are covering an index, and we can keep track of the intervals, right? And once we use up a point, we can remove the interval count. So this is actually a long shot, but since we are running short on time, let me try out this idea, see where it leads us. So how do we do this? Hmm. You have to take this array as an input and this. Okay. So you define the size as a dot size, and now you first find out the maximum element. So mx max element, or let's say mx is equal to star max element a dot begin a dot end, and let's create a points covering, and let's create intervals covering. And this will actually not be n, let's create it as mx plus 1. Actually, in fact, actually let's do mx plus plus to avoid some corner cases, and let's also do this like mx plus 1. So for each index we will be able to track how uh, many intervals cover it and how many points cover it. And how do we do that? So you iterate through each element. So integer I0, I less than m, or I less than a, I less than n, I plus plus. Now you do integer x is equal to ai, and the formula that we just discussed, what was the formula? So if x is odd, then you take the floor. So you do integer r is equal to, you want to define this integer r. So if x modulo 2, if x modulo 2 is not equal to 0, so is equal to 1. So if x is mod, if x is odd, then r should be x by 2. And we said that was it achievable or not? Yes. So there is this inclusive bracket, so that is achievable. Fine. And else if x is even, so r is equal to x by 2 minus 1. Okay. If this is the case, then this x by 2, right? It could as well be become 0, right? Like if r is equal to 1, then so what happens when r is equal to 1? Then 0 till 1 is achievable, right? So if x is equal to 1, then r is becoming, wait, if x is equal to 1, we said that this floor is achievable, but for 1, 0 and 1 both are achievable, right? Because 1 modulo 1 is 0, and if you keep it, now for interval thingy, you can just say 0 till 0 is achievable, and this value acts as 1. But yeah, I think this should be fine. R is equal to x by 2. Otherwise, R is equal to x by 2 minus 1, and you can say max of 0. And I know that some of you might say that there is a fancy way of converting this x to x plus 1 by 2 and then not having this if else, but since this is a contest setting, I prefer to explicitly write down this x, this R. So then what is the intervals contribution? So you say intervals covering of 0 plus plus, because you just found an interval, and then intervals covering at R plus 1 minus minus, right? And then you convert this interval to a, you will have to convert it to a prefix sum array to get that desired result. But is there an easier way? I'm just thinking. Mm, mm. How do we efficiently track how many intervals are covering it? Like, and the fact is that all the intervals start at 0. So this is a big factor. So do we really need to maintain prefix sum and then difference array and whatnot? Can we not just store till this point, like how many intervals we're covering it? I think we can do that because we know that all the intervals will start at 0. Maybe let's try that. We say that interval covering R plus plus. This means that, okay, so this means that uh, at this R you have one interval that is covering it, but then when you are doing this sweep from right to left, you will have to remember all the intervals covering on the right hand side, and then you have to propagate it forward. So this is kind of like prefix sum and difference array, but dynamic in nature. So I don't know if I'm making things unnecessarily complex, but we'll see. 27 minutes remaining. So we do this, and then we do points covering of R. So sorry, points covering of x plus plus. Okay. Then you want to do your binary search. So you do integer L is equal to 0. R is equal to the length, the maximum max can only be up till L. And you do while L, and you do answer is equal to -1, while L is less than or equal to R. You compute the midpoint is equal to L plus R by 2, and you want to find out whether the max can be greater than, can max be greater than or equal to mid. How do you find this? So you define, like, let's say check. This is how you write a lambda function. I hope so. you define a check with max, or like let's say m. 26 minutes. Okay, this might be the last problem that we'll have to attempt. No suitable conversion. Integer m. I think it should be auto. Yeah. And then you want to check if it's possible to achieve max greater than or equal to mid. It means that you have to cover all the elements from 0 till mid minus 1, right? So you start iterating from point P is equal to mid minus 1, P is greater than or equal to 0, P plus plus, and at any point P you first check if there is a point covering it. So if points covering of X, if points covering of P is greater than 0, then you use the point greedily. No, should you use the point or should you use an interval? But there could be multiple points covering it, but then it doesn't really matter. So if points covering this, how do you use the point greedily? You have to decrement the intervals covering of R minus minus, right? But then again you would need this same function over here. So I would define a lambda function over here, get R. So get the right endpoint, and you do something like you take in this X and you have this entire logic over here. And you return R. And here you define integer R is equal to get R of AI. And this is A of I. So intervals covering of get R for this. But now you also have to maintain which points were being covered, right? So it's not just plus plus. You actually have, for the points covering, you have to record which intervals. So you have to do something like this, vector of vector in points covering, and you define it like so. And here you have to push back the index, so that, no, not really the index, the value. So you push back A of I. Points covering of points covering A of I dot pushback. No, I think yeah, I think we don't really need to. Yeah, we didn't really need to do that, because if the point is being covered, then it can only be covered by the value equal to P, right? So we already had that deduction. So we don't really need to convert it to a vector. So if points covering of P, then you get the interval for this P, which is just this. and you subtract that count over there. And then you have used the point greedily. So the intervals covering, since you have used the point, it cannot contribute to the interval, so that's why you have subtracted it. But then since you are sweeping from right to left, you also have to keep track of the cumulative longer intervals that you have encountered, right? So you can keep track of this interval covering count is 0, and you do something like for integer p is equal to mx p is greater than or equal to m p minus interval covering count plus equals to, or let's say just the IC count. How many intervals are actually covered? So IC count plus equals to intervals covering of P. Okay, and if the points is being covered, that's good. Otherwise, else you update your IC count. So even if the point is being covered, "20 minutes to go. Will we be able to make it?" So when you encounter this element, because my main concern is that this get r function, right? This could be equal to p, so you might have to remove the contribution right from here. So we should instead, yeah, we should actually add the contribution. You could do something like, now if this is true, then if this points covering, you could do something like bool this point p covered is equal to false, p covered is equal to true, else here you have to cover it via an interval. So first you update your IC count plus equals to intervals covering p, right? And then if not p covered, then IC count minus, and you cover p with that interval. Is that correct? Yeah. And then if p is not covered, but if interval count is equal to 0, then p cannot be covered by either a point or an interval. So you return false, else you return true. So can max be greater than or equal to mid? You check. If check this mid. If it is greater than or equal to mid, then you don't have to look on the left hand side. So you can do L is equal to mid plus 1. Else R is equal to mid minus 1. And answer is at least mid. And you do see out mid this. So hmm, mm, okay, see out answer. Okay, honestly, I have no clue whether this will even compile or this will even pass the sample, but let's check. G++ c.cpp. It didn't even print anything. Why? Okay, test case n and the number. I did call solve, right? It is printing this answer over here. This is C. Input n array. It should have printed something. Why is it not printing anything? Why is it not printing anything? C.cpp. Is the input correct? Yeah, input is correct. It reached till here, but then it returned early. It reached till here as well. But what is even happening? Why is my code not compiling? Just 12 minutes remaining. What is going on? See out starting binary search. So binary search did got started, but while L less than or equal to R, integer true or false, see out got answer. So confused right now. Let's say it returns a bool. What about now? Hmm, I don't see a return statement over here. L is less than or equal to R. Let me write we have reached here. If check. Okay. Hmm. I don't know, something wrong with my lambda function. Let me just implement it. Raw. What is exactly wrong with my lambda function? Let me check one of my old code. Okay, it's not there. Let me do something like git grep. Why is my function returning early? Okay, I don't think I have any other option. I just have to copy this part and run it manually over here. So you do something like bool check is equal to true, and you define this as m. You do check is equal to false, and you do a break. Okay. So if check answer is equal to m, let's see. Why the hell is it not printing anything? Oh, is my program crashing or something? I guess so. Okay, I think we can go back to the old check definition. I think it is crashing somewhere. That's why it's not printing anything. We have 7 minutes left. Let's see if we can figure that out. Where is it crashing? So you start iterating from mx and intervals covering its hash size mx plus 1. So we are good there. P is greater than or equal to m. Okay. P minus minus. It should not crash over here. Points covering of P. Oh, okay. So here I should have been doing P minus minus. So 5 and 6 do we have? Let me comment out all of these. 4256. It's a miracle that the samples even work. Honestly, I did not expect even the samples to work. But let's see. I honestly have no clue whether it will pass or not. But let's see. It doesn't. I mean, that is kind of expected. I mean, I'm really not that confident about the logic, but mm, next to the center center was covering of P. Okay, that's fine. Yes. Get R for this P. Points covering is fine. P covered is true. If not, P is not covered. Is count minus minus. Interval coverings of get R P minus minus IC count. Can you make max greater than or equal to M? So all the points from 0 to M minus 1 should be covered. If IC count is less than 0, if it's equal to 0, then you use one interval that is covering it. What is the error? Points covering of P. Get R for P, intervals covering of P. Hmm, 2 minutes remaining. Points covering of P. Intervals covering at this P. I think this looks correct. What I'm missing? L is 0 or and R can be maximum. What is the maximum that it can be? It can be the length of the array only. That should also be fine. Max be greater than or equal to mid. L plus R by 2. Okay, the contest is over. I could only solve two problems. Not a good performance by me. But hey, at least we got the second problem, the GCD idea. And the third problem, I think maybe I complicated it a bit too much. Like maybe the binary search idea is still correct, and maybe that formula that we derived, that is also still correct. Maybe I'm missing some implementation details or something. I will check after this contest. Anyway, I think the goal was not to do an overkill. I think I did that again. Maybe next time things will change. That's all for this video.